Hi there. In this episode, we'll be discussing what does it take to build responsible, high-quality AI. Welcome to the Productive AI podcast, where we aim to simplify AI and make it more accessible to business leaders. I'm your host, Troy Agrodon. If you're interested in how to build AI for good or responsible AI or ethical AI type systems, you're in the right place. Today, I have Will Uppington from TruEra, and he's going to walk through the history and sort of the current regulatory environment in the space and talk about what it means to build a responsible or ethical or high quality AI system and how do you get there. So let's just start with a quick hello, and we'll get Will on the screen here. Will, thanks very much for joining us today.
Thanks very much for having me, Troy.
This is going to be a fun conversation. I think it's a very timely conversation. There's a lot going on, so I'm really looking forward to getting some of your thoughts on some of the regulatory stuff that's come out of the European Commission.
Yeah, absolutely.
So without diving into that too quickly, I just want to sort of backtrack. Now, you've got a pretty interesting background. You've been building companies for 20 years. You've led product and business development and customer teams at a number of different successful startups: Bloomreach, Clearwell, Neoterras, NetScreen. So you come, with this incredible background of building technology companies, and you've also got your MBA out of Harvard. So what's an MBA from Harvard doing in the responsible AI space? How did you get here? Why are you here now? Why this? Why now?
Well, after I graduated business school, I was focused on really working at startups. I wanted to help bring new technologies to market. And I started in a company called Neoterras, and then got to a company in search and analytics called Clearwell, and my last company is called Bloomreach, and there I was running product and some customer success teams, and we started to leverage machine learning in that product. And I realized that the black box nature of the technology was a real hindrance, both in terms of developing machine learning based products, but also in terms of selling and building trust around that. And then this may be familiar to a lot of other people, but when your machine learning application does a really good job, everybody thinks it's magic. But the second that it makes a prediction that doesn't jive with what people think, then you start getting a whole bunch of questions about why would it make this kind of mistake. And of course, people that know machine learning applications know that these models are inherently imperfect. And so once you get those questions, the view of the magic, that this is magic, starts to break down, and you start to break down trust, and that's what leads to people potentially not adopting the technology. So I felt that in order to adopt the technology, because I felt AI has a really great potential to help the world, we really needed to solve this black box problem. We needed to solve this problem around trust, and to your point around, and what we've realized now is the problem is really around AI quality, and that's actually a superset of all these issues around responsible AI or ethical AI, or all the things that you mentioned in that intro. So my co-founders and I started the company in 2019, and that's essentially the focus of the company, is help people build higher quality AI systems to address all these emerging challenges in that area.
Okay, excellent. There's a great quote I wanted to ask you about, which was actually from Amin Kazerouni. So I'm going to reference a few different quotes, and these were all from an excellent talk called Operationalizing Responsible AI. It was actually at Sam Charrington's TWIMLCon, which was a few months back. And there were a number of really excellent panels. This was one that really stood out for me. And there was a great quote in there: the currency of a data team or an analytics team is trust, not data. In other words, that's the output. That's really what you're building when you build one of these systems. Do you agree with that or disagree with that? Is it too narrow?
Yeah, I think obviously the data is a prerequisite, but if you want your machine learning application or your analytical application to be used in the real world, you have to have trust. So I think they're just two absolutely essential ones. If you're producing an analytical output that people don't trust, it's just not going to get used. Sure. Similarly, if you're building a machine learning model that is making predictions that people won't trust, then it's not going to get adopted. And that's actually what we're seeing in the industry, is that people are building tons and tons of models, but only a very small proportion of those models are actually being moved into production.
Right.
And I think that trust is absolutely one of the main reasons for that. There's some infrastructure operational related issues as well, but in terms of
Sure.
getting stakeholder buy-in to actually adopt machine learning, trust is an absolute necessity.
There was an excellent quote in that same talk. Actually, it was a panel. Todd Underwood, the engineering director for Google, and he said trust is inversely proportional to the damage that can be caused by the model in production. And he said there's just so many folks that say, "Hey, great, you got it halfway. You got it through development. You're about to put it into production. At this point, I can't trust the business with it. I'm taking on too much risk from the model itself, model risk management, essentially." So I thought that was really interesting. So how do we get there? How do you get to trusted AI? What's the missing piece here?
Yeah, I think that we think that the big missing piece is about AI quality, and I think there's an analogy that can be made to the software world when enterprise software was first being developed in the 1980s and 1990s. Is that at that time, there were all these stories about software and the challenges in building software that was actually delivering on what it was intended to do. You had these stories of software projects that were over time, over budget, and when they got delivered, they didn't meet the needs. And this was something that was quite a well-known thing in the news at that time. And I think we're going through something very similar in machine learning or in AI, where people are realizing, and data scientists and machine learning engineers are realizing that, assessing the quality of your model by looking at kind of global accuracy metrics is not really enough, that you have to have a much broader kind of understanding of what quality means. And it really, in our mind, what quality means is everything you need to do to your model to help it deliver on the KPIs you're trying to hit in the real world. And so you can't just be thinking about, okay, does my test, when I apply my trained model to my test set, what kind of global accuracy metrics does that provide? Because as we all know, the test set is always an imperfect representation of the real world. And so you're inevitably not going to capture all the different elements of the machine learning evaluation that you need to if you want to understand how well it's going to work in the real world. So we think that what companies need to do is they need to develop systems around improving the quality of AI. And in doing so, that's what's going to help them be able to engender this kind of trust. Because to your point, Troy, when you have certain types of applications, people are going to be thinking about, okay, do I see any kind of problems in my face around the model? And if you see problems, then they'll probably be inhibited from moving into production. But as you get into more and more kind of riskier or situations that Todd was mentioning, where the potential damage that could be caused is significant, people are going to not trust unless because of the unknowns. They're going to say, well, there's so many unknowns, and that's going to inhibit my adoption of the AI. And so building out a quality system that kind of reduces those unknowns is what's going to enable people to adopt machine learning for more and more applications. So in the end of the day, we think that all of this comes back to being able to understand, evaluate, manage, and monitor AI quality.
I think what's been interesting for me about the whole AI industry is looking at all of the patterns that we need to bring forward from everything we've been doing before this. As you just said, we've been doing quality management in manufacturing and then eventually in software for decades at this point. We've been doing software development life cycles for 20, 30 years. And that now we're having to sort of morph those and change them, mutate them a little bit to create model development life cycles, right? And then merge those two, the model development and the software development, into kind of product development. So I think what's interesting is just seeing how we have to keep going back to the past and saying, what are we missing? Let's bring it forward.
Yeah, absolutely. I mean, every kind of industry or new technology that has gone through this kind of maturity curve, where you get the initial use cases and you get these initial wins that show the promise, and then in order to really kind of institutionalize and really be able to scale it, you inevitably have to start thinking about quality and consistent quality. And so what was the response to the kind of software quality crisis was people developed a whole host of new software development tools, and they created a whole new set of methodologies like agile software development methodology. So that's the same thing we think is going to need to happen. And our company's focused on building a lot of those kinds of tools. And we think that, around that, there's going to be new methodologies that are coming to the fore as well. And a lot of that should come from the industry, but I think we're now, because there's such a high sense of focus on this in the broader world and broader society, a lot of that's also going to come from regulation, because people are thinking through the potential trust issues and responsible AI issues, and they're starting to impose regulations in order to make sure that companies do this. And a lot of these things have been done before in other sectors. You mentioned, Troy, model risk management in financial services, for example. Mm-hmm. And that is going to be expanded. And those kinds of regulations are going to be expanded to a much broader set of use cases, because with AI, modeling is now being expanded to a broader set of use cases.
Yeah, and I think in model risk management, that almost seems like, that's too late, right? Oh, well, it incurred some risk, or it's about to incur some risk. How do we mitigate that? As opposed to how do we stop it way further up the chain by building high quality systems up front versus waiting to the end to see what the damage could potentially become. So speaking of sort of AI failure cases, now there have been a number of really high profile kind of AI failures or challenges, whatever you want to call them. Now, for folks who aren't familiar with this, can you give some examples of like what's happening in this space? How are these models failing, and what is the impact on either the customers or the businesses or both?
Yeah. So I think that there's been a lot of attention drawn to kind of AI failures. So there was I think some cases where there was an IBM system that was trying to predict certain kind of diseases, and it just didn't do a very good job in doing that. And it's obviously a very high risk kind of situation if you get those diagnoses wrong. And I'm not sure if this was even really AI, but there was this extends to algorithms in general. Most recently, there was a controversy around British schools where they used an algorithm to do grades because they couldn't take exams due to COVID. And the way the algorithm works was fairly rough, shall we say. It was a kind of a coarse way of doing things. And so it provided some bias against children who were in lower performing schools, but may have been higher performing students, that their projected grade was not as high as it might otherwise be. And so they felt that there was some unfairness around that. And you actually had people protesting in the streets saying swear word, the algorithm. And so that became pretty high profile. And that brings up also the other big areas of concern that people have, which is around bias. And there's been a lot in the news around that lately. The example always people say it is that Amazon created an algorithm around hiring and actually stopped using it because they found it to be biased against women in terms of hiring technical technical roles. And then you've seen that there's there's a lot of concern around facial recognition systems, where facial recognition systems have been known to have weaknesses against more minority types of profiles, where they don't do as good a job with people of different skin colors and the like. And that's raised a lot of different kinds of concerns. Mm-hmm. So those are a few of the buckets, kind of just like failure systems in general, when the potential for damage is high, or things around kind of fairness and transparency and things like that. The FTC has recently put out a new blog post in this area, and they cited a couple of different examples of people using AI in ways that they felt were unfair. One was a car dealer around Honda vehicles. And so it's definitely getting, the number of stories are increasing, and they're definitely getting increasing attention as people are paying more attention to those stories.
Perfect. So where do we go from here? It sounds like we've been building these systems for a while. As you rightfully pointed out, it's not just AI models, it's all algorithms. We've been building algorithms for many, many years. And of course, many of them can be flawed. And now we've got these more complex models, which can also be flawed because they're built by humans who are flawed, and and their statistical distributions, they're going to make mistakes. What do we do to sort of improve the overall situation? What are the levers we can pull? How do we get to higher quality? If the theory is that higher quality production equals higher trust, how do we get there? And I have a couple of different dimensions, I guess I want to talk about that in: the people, the team, the processes. Back to that talk at TWIML, the thing I loved about it was called operationalizing responsible AI. And they talked about how did they train their team? How did they structure their team? Where in the product development lifecycle was that team working? And where was, ethical and responsible AI in terms of training, which turned out to be their entire organization. So I'm wondering what thoughts you have on that. And then after that, we can maybe talk about some of the regulatory environment.
Yeah, absolutely. I think it does come down to, software technology to aid in the development of machine learning. It also comes down to processes. And then, as you said, it comes down to people. In terms of the software, this is an area that we're focused on. I think that there's a tremendous amount that technology can do to help make it easy to build higher quality AI systems. Because if it's too hard to do that, then it's really going to create friction in terms of adopting, in terms of making the improvements across both across people and process and
Sure.
technology. So, in particular, there's a few technology developments that have really helped in this regard. One is in AI explainability. So actually, my two co-founders, Anupam and Shayak, started doing research in this area over 7 years ago and wrote some of the foundational papers, one being in 2016. So this is an area that has been a focus from the research perspective in academia for quite a while. And now I think it's really ready for prime time. They were doing this work at Carnegie Mellon, as I mentioned, 5 to 7 years ago. And now these technologies around AI explainability can make it really easy to understand exactly what the machine learning models, even what the machine learning models are doing, even very complex ones. So we work with customers, anywhere from, kind of traditional tree ensemble, random forest, gradient boosted models. But we can also work with neural networks and the more advanced and thus more complex models as well. And in many ways, we can really make these models as explainable as older school technology like logistic regression models. There's no reason why they can't be as explainable. So that's one foundational piece of technology that's in place, but that's not really enough. That's kind of the keystone to this. But what you then need is to create a whole range of software development tools to really go after that kind of quality problem. And the way we break down quality is we think about 3 different categories. There's model quality, so that's the quality of the model itself. There's the data quality that you've used in order to build that model.
Sure.
And then there's that model development, process. And we think that all 3 of those are important, and that software can aid in all 3 of those: assessing the model quality at a deeper level, assessing your data quality, and then helping facilitate a more quality-oriented development process.
When you say model quality, how do you break that down? Based on dimensions, I guess.
Yeah, I'd say there's about 5 dimensions that we think about. So first is we think of kind of conceptual soundness and model reliability. So this is where there's kind of a risk of being weakness in the performance of your model in the real world. This could be because the model, because of bias in the training data, has not really well understood how you should think about a particular feature. It's like in a credit decisioning model, for example, we have a public data set we use in order to build credit decisioning models. And in this data set, there's this weird situation where there's a set of users that have particularly high debt to income ratio, but they're viewed as low risk by the model. And that's because there was kind of an actual issue in the data quality. There's another piece where somehow the model views people with income of $125,000 to $150,000 of income as being less risky, as being more risky than people with $100,000 to $125,000 of income. Those are examples where overall the global accuracy metrics are pretty good, but when you look at these more micro slicing levels, you see that there's real weaknesses or problems. There are other situations where your model could be making a strong statement, but actually not be very confident about that statement. All statistical models have confidence bounds, for example. So that's one area, conceptual soundness and model reliability. The second is about explainability and enabling in human and machine collaboration. So how can you explain how your model works to stakeholders? The third is in bias or unfair bias. The fourth is in looking at the segment level versus just at a global level. In any kind of application in business that you're applying your machine learning model to, there's always going to be segments of the business that are more important than others. In a lot of businesses, there's a small percentage of the customer base that drives a lot of the revenue or a lot of the profits, for example. So I remember I was working with Neiman Marcus in one of my prior companies, and they kind of cater to high, very wealthy individuals. But even then, there was a small set of users, of customers that actually drove a vast set of their kind of profits. So that segment is going to be more important. And if your model doesn't do a very good job on that segment, then even though it does a really good job globally, then that can also be a problem. And the fifth area is really about model stability and monitoring. So the world is obviously changing. Coronavirus is the prime example of that. So how is your model going to continue to perform in an ever-changing world, given that many models can't be constantly, refreshed and retrained, and even if you can, the amount of data that you need in order to build a model, can be greater than the slices of data that you would want to train your model on. I think everybody building models right now for any kind of that is trying to predict any kind of behavior that's affected by COVID and lockdowns is in a bit of a pickle. Because if I train my data on the latest data where there were lockdowns, then after the lockdowns are ended, the models are probably not going to perform very well. But if I train my data on pre-COVID, then the model is not going to perform very well during COVID. So those would be conceptual soundness, explainability, unfair bias, segment level metrics, and model stability and monitoring.
And all of that fits under the broader umbrella of model quality. And then what were the other two points there?
Yeah, that's model quality. And then you've got to also think about so that is in some ways the replacement for analyzing your model just kind of on global accuracy metrics.
Sure.
Those kinds of things.
It's a deeper look. There's a sanity check. There's a segment check. There's a bit bias and is also taken into account there.
Yeah. And if you think about all five of those things, if your machine learning application breaks down in any one of those five, it's not going to deliver on your KPIs, and thus we don't think it's a high quality model. Even you could have great global accuracy metrics, but it's not going to work in the real world if you don't consider all five of those things. Then the other thing is data quality. So garbage in, garbage out, right? Is everybody knows that. So it's critical to think about data quality. What's that?
Always been true and always will be true.
Yes. Yeah. So, and many of those same model quality aspects can be, taken to the data quality side, because a lot of those where you see the model quality issues in model quality can be a source of due to the data quality as the source of those problems. And then the third area would be, what is your model development process? So, we have a fairly established set of software development process now. Most people follow agile methodologies, and there's a whole bunch of infrastructure built up, to help people follow those kinds of methodologies. That doesn't exist for machine learning. A lot of machine learning is really ad hoc right now. People just running kind of experiments, and oftentimes if you get good global accuracy metrics out of those experiments, but maybe don't even understand why, you kind of move on. I think getting a more systematic kind of approach, where you're constantly analyzing your model across all of those model quality and data quality dimensions, and doing that iteratively, and then understanding when you run a new experiment, what changed, and then understanding why that changed, and then systematically building on top of those iterations versus just, okay, that one didn't work, off to the next one. That's where I think the model development process also needs to improve.
Right. On the data, backtracking for a second, the data quality thing, I think it's been really interesting to see Andrew Ng, who I'm sure anybody who listens to this podcast knows who Andrew Ng is. He's one of the forefathers basically in the industry. And he's been out really pushing this idea of moving towards more of a focus on the data. And he said, I think the quote, I'll paraphrase and I'll probably do it poorly, but it was something like, when we're working on a project, we're trying to solve a business outcome, fairly quickly into the process, I will say to the development team, the model is good enough for our purpose. Now go back and fix the data. And he goes, we get more bang for the buck and we get more output of accuracy at the end of the day by going back and refining the data and having cleaner and better data and more better fitting. That's a wrong, I don't want to overload better fitting, but more accurate data to what we're going to see in the real world. That's cleaner, less noisy, that essentially helps us get to production faster. Do you have any thoughts on that?
Yeah, I would definitely agree with that. I mean, in my experience, it's always getting better data or new features or more features in your model has always been the way to improve the performance of that model. That's where you do get the bigger bang for the buck. I would say that, one perhaps kind of addition to that, I would say, is that it is about data quality, but it's only about the quality of your data through the eyes of the model. And what I think is happening a lot now is people spend a lot of time doing data prep and thinking about that data without actually having run a model against it. And the potential inefficiency with that is that you could be potentially doing a lot of things to create a better data set, but it actually doesn't matter. You can add new features to a model, and it actually doesn't improve the discriminatory power of the model in a significant way. So I think in terms of this improvement in model development process, now that there's these additional tools around AI explainability and kind of whether you call them model intelligence systems or AI quality management systems or explainable AI systems, what you can do with those is you can be more agile in the process by which you improve your data and make sure that that's improving your model by building a model earlier in your process, using these tools to evaluate both the model and the data quality through the eyes of the model, and then using that to prioritize what you next do in terms of building your better data. Andrew Ng is right in that you'll get more bang for the buck by improving data, but that's in general. You can find that you can go get a new feature and spend a lot of time getting a new feature, and that feature, once you put it into the model, doesn't add a lot of value potentially, right, because it's already correlated with another feature that's already in the model.
Sure.
And thus the importance of that feature or all that time you spent going to get the data, it isn't very high. So I think that, kind of thinking about your data quality and where you should go to improve your data should be done through the eyes of the model versus just kind of standalone.
That makes me think of yet another. There were so many great talks at this TomoCon, but there was another talk from Jennifer Prendke, Dr. Prendke from Electio, and she came out of the data prep world, and she said her whole pitch was data prep operations is a complex set of operations and should be treated as such as it is with model development, number one. And number two, you can't do good model development without good data prep operations, and that being an iterative cycle, which is, I think, what you're saying.
Yeah, absolutely. I think that, and I think our tweak to that would be don't do data prep, in the absence of understanding how it actually affects your model and your business case.
Right. Don't do it with in that isolation.
Yeah, exactly. Don't do it in isolation, because you could theoretically do a ton of work to make sure you identify potential statistical bias in your data set, but that doesn't matter at all when you actually go build a model.
Yeah.
So I
think you're in agreement.
Yeah, definitely in agreement. But the idea would be build a model as soon as you can.
Yeah.
and then go back to the data and go back and forth between the model and the data.
And cycle them at that point.
Yeah, exactly. Iterate on that. What we would think is the way to adapt agile methodology to machine learning. It's creating that iteration between the data and the model and thinking about what you've done from the data side and what's the incremental value of that through the eyes of the model.
Right. And then, so this third point, right, we've got model quality, which has the 5 subcomponents. We've got data quality, which we're really, I think, agreeing violently here that essentially it's data quality and model quality, and they're sort of interlinked and they should be iterated together. And then the third piece being this model development process. This is something that's kind of near and dear to my heart. I'm doing a lot of studying and listen to a lot of folks in the space who've been building these systems for years. And what became very clear to me coming out of the cloud space and out of a lot of software development was exactly what you said, which is we have tools, we have processes, everybody understands the general approach to Agile, whether they're using Scrum or Kanban or whatever. They understand Agile development. We have the sort of whole tool chain is there. The platforms are all interlinked, and you can say, great, I stand up an entire end-to-end software development process. Anybody I hire is going to know how to use that to build pretty good software these days because we've been doing it so long. And that set of processes and those tools and those platforms are not baked, and they're moving very, very quickly. I call it quicksand because the ecosystem is exploding, and all of these platforms and tool vendors are saying, we do everything. And the reality is, if you look under the hood, maybe there are 40 or 50 things that they should be doing, and they do 20, or this one does 10, and this one does 3, this one does 1, but it goes super deep. And so it's like, how do you assemble that set of tools in order to have an end-to-end process that is thorough, that can produce high quality, output? And the reality is it's just not baked yet.
That's right. Yeah. So, and I think that there is kind of this kind of differing views of whether you should kind of have like a single platform or a suite, if you will, or more best of breed.
Right. The ongoing debate in every software domain, right? For decades.
Yeah, every software domain kind of has this. And I think, the answer to that, it depends on each company and your ability to kind of manage through it. I think that in the early days of a new software area, it tends to be that being a bit more best of breed makes sense because there's so much innovation that's going to occur in each of these areas. It's not really practical for any one software company to kind of offer everything and do it well. And so I think early on, it makes more sense to think about more best of breed. Over time, I think as the technology is more mature, through acquisitions and through things like that, or just time, then it'll be more viable to go with kind of an all-in-one, kind of solution. But right now, I think that it's just impractical to imagine that any one vendor is going to have like an adequate all-in-one kind of solution, just practically. So I think if you go with an all-in-one solution, you're inherently going to be not having access to the latest and greatest, technology, but in a very significant way.
I think the counter to that is that what you are seeing is, and we've seen this pattern. We saw it with NetSuite for Salesforce, right? Salesforce said we're going to go super deep, but only in one function, being sales. And then NetSuite said we're going to go instead. We're going to cover every function in your business horizontally, but only an inch deep. And they sort of like took these completely different approaches. And both of them were valid. Both of them became very, very
well, and for different kinds of customers, right? So,
yes, exactly.
For smaller customers and things like that don't have the time to manage that complexity thing, that I think that was viable. But also, I do think that NetSuite came after, Salesforce, where, there were, I could be wrong in that, but oftentimes when you get that, there's some pioneer in like a software space, they kind of pioneer a lot of the functionality. And then it's after that where you figure out, okay, they build 100 features, but actually only people really use like 50 of those features. So I'm going to be a more broader, offering and include a bunch more, and I'll just focus on those 50 features. I won't have the 100 features, but I'll have a subset of features. So in order to figure out what's the subset of features that really works, that does take or that you really need, that does take a little bit of time to establish.
Yeah, for sure. No, it's a very interesting time. I'm looking at the ecosystem a lot, and definitely that sort of like horizontal end to end versus very deep, functionally very deep single point solution, or do you do a combination of the two, have a platform and then have some sort of deep components that you tie in through some integrations? That's an option too.
I think they're all viable,
I think what's become really clear to me in looking at the space is that the era of, well, I'm just going to get a bunch of open source components, we're going to build our own stack. I think that's over, frankly, because who could do that? Well, the top 20 largest web scale companies in the world did that, and they built it multiple times. And they built multiple versions of them. Nobody else can really afford that technical debt. So I think at this point, it's sort of coalescing and collapsing into, what do I buy? Not is it build or buy, it's what do I buy and how do I stitch those things together? So we'll see how it plays out.
So I think the open source is a really interesting topic, because there in so many of these areas, there are open source elements. But I would tend to agree with you that I think that I would say two things. You can only go so far with open source, and then it's in somewhat ironic, but at least in some of the areas like AI explainability, we find that while there are open source technologies out there, oftentimes people don't fully understand how they work or how best to use them. And so just because something is open source doesn't mean that it's infallible or the perfect thing to do. There's some open source technologies in AI explainability, for instance, that can be in certain situations really wrong. But people just kind of, use these open source packages, calculation feature importance scores, and think, because the package doesn't tell you when it's wrong and when it's right. So you have to be even, the irony is that even though it's open source and you could really understand exactly how it works, people, often don't really understand how it works.
Because they don't dig into the code. I mean, this just gets into the whole side, conversation about open source versus closed source, which is a much longer conversation. But I would agree with that. So let's talk about the regulatory environment. I know we're coming up on time for this podcast. But so what's happening? I understand there's a ton of stuff. I don't understand a ton of stuff. Let me backtrack. I have heard there is a ton of stuff happening in the EU. Could you just explain what's happening over there? How does it tie into this whole conversation?
Yeah, in late April, the European Commission came out with a proposal for something called the Artificial Intelligence Act. And what the Artificial Intelligence Act does is it requires companies that are using high-risk AI systems to essentially have something they call a quality management system that achieves regulations in a number of different areas. So the areas they kind of stipulate a set of regulations around high quality data sets, record keeping, transparency, human oversight, and accuracy and robustness and security. So if you remember in the prior discussion we had about there's model quality, there's data quality, and then there's processes, this actually creates regulations for across all of those. And the companies in these high risk sectors that they designate are going to have to adhere to these regulations and file what's called conformity reports. And that's something that they need to do, whenever they put out a commercial AI system in some of these designated high risk areas. So this is a proposal. It's going to go through a process of being approved, but typically the European Commission doesn't put these things out unless there's a pretty good high chance of them being approved. But we'll see. But in effect, this becomes like the GDPR of AI. And what happened with GDPR is that these regulations really kind of set the tone for the rest of the world. And what you see is a lot of other jurisdictions adopting elements of those. And some of that has already happened. So there have been a couple of privacy acts that have been passed. So most recently, there was a ballot measure in California called the California Privacy Rights Act. And in part of that, there are elements around automated decision making, where you will be required to explain automated decisions. So that will cover, AI as well. And then in the U.S., most recently, the FTC made an announcement that they were going to pay more attention to this stuff as well. And I think the words they used was hold yourself accountable or be prepared for the FTC to hold you accountable. So the EC regulations are really kind of the headline of a whole set of regulatory developments that are really across the world. But the EC would be the most kind of direct AI focused legislation ever put in place.
And what's the, we've seen that pattern play out, as you mentioned, GDPR, right? That just rolled across everybody. It's almost like California setting a regulatory environment inside the US where all the other states say, oh, well, we'll just follow that because that's we want to be in that market. Therefore, we might as well make one version of everything. And if we can get there, we can sell everywhere. So I can see the same thing where the EU kind of sets the bar, everybody else follows suit, and it kind of is the great leveling as because everybody wants to access all these different markets and play in all these different markets. So what's the sort of real world impact of that right now? How far out is this potential, impact from this regulation?
Yeah, it like GDPR, I think they're going to try to pass it sometime this year, maybe, but there'll be a time period before the regulations get put in place to give people time to adhere to those. Practically speaking, I think that's going to be a couple years out, but what you tended to see with GDPR was that, once it gets passed, everybody starts working on it essentially because they know this is coming. So I think once it gets passed, I think people will likely start working on it. And for these high risk, kind of systems, they're essentially going to need to put in these AI quality management systems. That's, it almost kind of requires that you either need to build or buy some software in order for you to conform to these regulations and put in place this quality management system that the EC mentions.
So is there a place that people can go right now? Is there an AI quality management, international standards body? Because I don't believe I've ever heard of one.
Yeah, no, there isn't. But there have been a lot of efforts, and oftentimes they're under the nomenclature of trustworthy AI.
Sure.
So there's been a bunch of guidelines around trustworthy AI. We're actually working in a consortium called the Veritas Consortium with the Monetary Authority of Singapore. They put out some principles called the FEAT principles, or fairness, equity, accountability, and transparency principles. And they did that. They were one of the first to do that. Hong Kong also did something very similar. And now there's a group of software vendors and financial services institutions that are working with the Monetary Authority of Singapore to put in place practical standards for people to adhere to these kinds of principles. So there's been a lot of work done in this area of trustworthy AI, and there's a lot of guidelines around trustworthy AI. I think that, and that's been more focused on particular segments. So financial services have long used models, and they've long had kind of guidelines around the use of those models. That's, as you pointed out, Troy, the model risk management principles that have long been in place. And so they've been kind of one of the first to build out, a set of guidelines around model risk management. And now those are being adapted, to machine learning. So you can look to a lot of those efforts. There's in the UK, there's something called the AI Public-Private Forum that's sponsored by the Bank of England and the FCA there. And then, I think that there are, the OECD actually has a tracker of all of these. There's tons of legislations and efforts and bodies like this around the world that are kind of looking at this problem, but there isn't really kind of one universally accepted set of standards. Something we're going to try to do at TruEra is provide like a research section of our website to try to give people a lot more of the practical ideas around explainability, trustworthy AI, responsible AI, and things like that. But I think it's an area that needs more kind of educational materials.
when I did a talk last year at Forward 50, which is a government focused kind of technology conference. And for the talk, it was really kind of where's AI being used in governments around the world. And it was interesting to me at the time in doing the research for that, finding all of these AI strategic plans that had all been released. I think it was 100 countries or something had released strategic plans, and we're starting to sort of build all that stuff out. So I saw that. I saw a lot of what you just touched on, the sort of AI governance frameworks, things like that. Yep. And to me, it's like an extension of corporate governments. It's the same for, right? Fairness, would you say fairness, accountability,
fairness, ethics, and transparency. Yeah.
And transparency, right? The standard corporate governance thing that's almost been ported over to become AI governance. But to me, it's just, I think it's really interesting that there's this, there are the governance principles, let's say, and then there are, and I think trust kind of fits squarely in there. And then there's this quality thing, which it sounds to me like you're almost saying quality is the foundational layer that gets us to those principles above. Am I misunderstanding that?
Yeah, no, I think that's what we are saying. And I think that's where there needs to be more work, which is how do you achieve AI quality, right? And how create that, model quality metrics and data quality metrics, and then the process that if you achieve that, or if you follow those processes, you will get good governance.
Right.
I think that's where, there's some foundational standards, for example, like how do you go about making sure that your AI does not have unfair bias? There's not like one way of doing that. And so over time, we've got to build standards where I think what companies need to do is they just need to adopt one way of doing that, that they think is based on good foundations and is applicable to their kind of use case, and then systematize that. Mm-hmm. And then, if they find better ways of doing that, then they can improve that. But I think the regulators are going to look for, do you have a way that you systematically analyze bias? And are you following that? If that way is imperfect, you're probably not going to get in trouble for that. But you'll get in trouble if you don't establish a way of analyzing bias. And then you'll get in trouble if the way that you establish and analyze bias, you don't follow consistently. So I think when companies are looking at adhering to these regulations, oftentimes these things are not spelled out. And so what you need to do is pick a method of adhering to these regulations and then do it consistently.
Right. And I think you'll see that in HIPAA or PCI or so many of these standards. And it's correct. They shouldn't be technologically prescriptive and say, you should have this database connected in this way to that database. That's not what their job is. Their job is to provide the guardrails and say, you should have these processes. You should follow those processes consistently. And these are the outputs. And as long as you do those, you've checked the boxes. And if we do an audit, we're going to check all the boxes and you pass.
Yeah, I think as long as you make a good faith effort to do that, I think you'll be fine. Probably the thing not to do is just to ignore all of this and not have anything.
Exactly. And I think that was one of the things that came up in the conference at TWIML was this idea that, everybody last year was saying, what's ethical AI? What's responsible AI? And at least for some of the big folks, because, Microsoft and LinkedIn, and these are the folks that were on the panel, and they're saying, look, we're so far down the track at this point. We're just trying to scale ethical AI. We're trying to do it across the board for every model. I don't think everybody else is there. They're sort of stumbling their way forward, building their first models or releasing their first products and saying, do we really have to do everything? Does it have to be responsible, or can we just get this thing shipped out the door? Because it's already hard enough just to get this thing into production. Do we really have to worry about the rest of this stuff?
Yeah, absolutely. I mean, that's where I think hopefully folks like us can step in and give you, in effect, kind of like an easy button for doing this kind of stuff. If it's too hard, it creates so much that friction. So we, in the software industry, that's what we've got to try to solve, is just make it as easy as possible to adopt these kind of AI quality management methods.
So at a very high level and very kind of simple overview, let's say I'm a company, we're building some models, we're trying to put some product or service into production. We have, let's say, a hodgepodge of tools, some open source, or maybe we bought a platform and we've got some extra sort of deep components. We kind of have a process, we can kind of get models built. Maybe it's not that repeatable, maybe it's not that fast, but we're getting the job done. How can your team sort of support that? How does that integrate in there?
Yeah.
And
So what we try to do, because we know that people may have built different kind of elements of it. So our software is designed to be quite kind of complementary and pluggable.
Okay.
So if you have built a certain method, for example, if you like using one particular AI explainability method for certain situations, our software can continue to work with that method. But in other situations where that doesn't work, we can provide other kind of technologies for explaining machine learning models, for example. Or, we provide capabilities around all 5 of those things that I mentioned, kind of conceptual soundness and model reliability, the explainability, unfair bias, segment level analytics, monitoring, and model stability. And can work with, if somebody already has something in place there, then we can work with that, either through kind of APIs that we provide or kind of a GUI kind of experience. So and then from a functionality perspective, we can be complementary to what people have already built. And then also from an infrastructure perspective, we try to be quite pluggable, and we can work with models built in any kind of development platform. One thing we find is that if you want to build a kind of an AI quality management system or responsible AI system, you've got to think about how you can do that systematically across all your different model development capabilities. And reality is that most data scientists want to use the best tool for the job, and that is going to create some diversity. And so we find people are using open source for this, but they may be using something like a data robot or an H2O, for example, or they may be using the tools as part of Amazon or Google or Azure, and they may be doing all of those. So you need a system that can kind of work across all of those to create this more systematic approach to quality management and responsible AI.
Yeah. And that makes a ton of sense because the variety is quite wide. I read a report the other day and it was financial services, very kind of AI leader types. And they said, look, we have at least 7 platforms and we've got, I think, an average of 270 models in production. And all those are split across teams all over the business, delivering functions and products and services in various units, organizational units or business units. So I think it makes sense that you guys can say, we'll work with whatever you have. We'll plug in and support whatever you have. If you're already happy with, let's say, your model bias or your data bias detection or something, then don't worry about that. We'll feed the data in.
Yeah, exactly. And we work with a number of banks, and that scenario, we've seen that scenario exactly play out. And what that creates challenges around is all the other teams that need to work with those different model development teams. So banks have already put in essence, AI quality management systems that they call the model risk management. And they've already got compliance methods around bias and things like that because they're already under, Fair Credit Reporting Act and things like that. So, and that's where, there's an interest in being able to do something systematic across all their different teams that are doing development, so that your, compliance teams, your model risk management teams, your AI quality team, doesn't have to create a different method for all these development platforms, because that's just not, not going to scale if you have different ways of explaining models, different ways of analyzing models, by your development platform.
No, that makes sense. One last point on this. I thought there was a really cool point that was brought up from one of the speakers, Sarah Bird, who's the principal program manager at Microsoft, when she was talking about this. And she said, what's interesting is we've tried to, and I think it sort of lines up with what we're talking about here, we've tried to make ethics and trust and responsibility and fairness and all of these things, weave them so deeply into our overall business process, our overall product development process, that we get in literally at the beginning of any new, hey, we're launching a new product and service, there will be some model component to that. And I think most people listening to this will realize that the model is the 5% in the middle and the product is the other 95% around it. So we're launching a new product. It does have a model in it, and it will be responsible for producing some sort of output, which is tied to the product. And they said, as soon as we launch a new product, if there is a component of that, immediately, we've trained all of the staff to think about the issues around fairness and equitability and transparency, so that it's everybody's job, not an auditor's job at the end of the day. and that we weave it through the entire process, and that they even have like things called ship rooms where essentially all of the folks who are building products can come and talk with those folks every day and say, hey, I'm wrestling with this issue. I'm about to release V2, or I'm in production, or I'm in development, and I've got these questions. Is this going to go a positive or a negative direction? But I think the overall takeaway was, we're trying to operationalize it, and we're not trying to do it by having bad people auditing the thing at the end of the day. It's more about teaching everybody to create good product, and doing that through training, and doing that through systems, and doing that through process. Are you involved in any of that stuff as your group? Because clearly you sell some software, but do you get involved in sort of the people and the process and the training element of all of this?
Yeah, we do. I mean, since it's new software, when we start working with our customers, there's often kind of a training element and a process element to it. And I would completely agree with that point of view, where sometimes we're starting and the way you're using us is a little bit, okay, I built a model, now I'm going to evaluate it for all these different checklist AI quality items.
Sure.
And that's sometimes how you start. But I think it was Sarah Bird you mentioned, to her point, that's not the efficient way to do it.
Right.
The efficient way to do it is to build it into the development process. And there are some very practical reasons for that. If you spend a bunch of time and go through 20, 30 iterations and building a great model with high accuracy, and then you give it to kind of an auditor, and then they do detect that there's bias in your model, and that bias is emanating for a certain set of features that were actually helping quite a lot, and you then go, and the simplest way is, okay, let me take out those features, right. And then the accuracy drops a ton.
Yeah.
And then a lot of the work that you've done is really wasted.
Right.
Because if the alternative had been that you had identified that potential for bias at the very beginning of your development process, you likely would have saved a ton of time.
Yeah. I think it goes back to the basics of quality, right? If trust is a requirement to ship your product, and trust comes from having high quality all the way along, as defined by the criteria you've laid out, then it becomes very important for folks to say, okay, I'm going to build this process in. I'm going to do, quality management from the beginning of ideation all the way through development and all the way out to production, versus letting it run its course, spending $1.5 million, or $10 million or whatever in 18 months, getting to the end and saying it doesn't pass. It's a pass fail. Go back and do all this rework. That's not solving anything for anybody. So I think more companies need to get that.
And it's funny because when you say it like that, it's reminiscent of what was the founding concept of agile model development, right? Because the whole point was you're gonna build, compile the software very, very frequently, right? And test it during your development for those exact reasons that you mentioned. That is why agile type methodologies have become the primary methodology for building high quality software. And so, what you just mentioned is kind of like taking agile and applying those same concepts to machine learning.
Yeah, I really think we need to. I think we already are seeing that agile AI will become a thing. I don't see a lot of documentation on it, but it really, for all the reasons we're talking about, which is, hey, I produced it, I did some data, I did some modeling, it's still trustworthy. I'm going to cycle through again. Can I improve it? And then can we continue to improve both its accuracy and its trustworthiness and its transparency and its equitability as we go through further versions of this going forward, versus the big bang, get to the end and pass fail.
So, yeah, and what you need in order to make that happen a little bit, it's the process piece, as you mentioned, it's the people piece, and then you need software to kind of make that easy, because a whole bunch of software that development capabilities were created in order to facilitate the fact that you can compile your software continuously, and so that I think is what we'll see. You need to be able to doing these AI quality checks continuously, and that needs to be very easy to do.
You are the Toyota quality management of this era, of this decade, bringing Toyota's 50, 70, 70-year-old manufacturing processes into AI and machine learning.
Hopefully.
Excellent. All right. Well, I think we're at the end of this end of the time here. In fact, we're a little bit over. So I have one more question for you. It's kind of a bonus question I've been asking everybody on the podcast, do you have any thoughts for career advice? Folks who want to get into the field, I'd say AI generally, but maybe specifically around this kind of working on the issues you guys are working on. Do you have any thoughts on that?
Yeah, I think that it's kind of the same thought that I have in terms of like, how do you build good AI is like, start now, start early, and iterate. This is if this is a passion for you, follow your passions, and just start learning, and start working on it. The best thing you can do is go get your first job. In order to go get your first job, like, what are the requirements you're going to need to get that first job? What is the courses that you need to do? What are the practical boot camps or things like that you need to do, and then just start reading a lot of this area of kind of AI explainability and quality management. A lot of it is come from the research world, and there's a whole bunch of different papers that are out there, and so there is a bunch to read in this area and get up to speed on, that exists. It's not kind of all in one place yet.
Right.
There's some ebooks online around explainability that puts a lot in one place. But I think it's reading and it's testing and trying things out, because a lot of this is experiential as well. There's a lot of things in AI explainability and AI quality that people just haven't done yet. So for instance, we came up with a new feature, which was that if you cannot recalculate your accuracy, how do you estimate your accuracy? We don't believe anybody else has tried to do that before, and it's a pretty hard thing to go do. And we think we've got a pretty good method to do it, but we've got to go test that out a bunch now and hone it and refine it. So this is kind of a little bit on the cutting edge. And when it's on the cutting edge, I think the thing to do is to get out there and try things and iterate.
Yeah. It seems like there's a ton of opportunity to go make your mark in this space, because so much of it is not yet baked. And I think about 6 months after the EU finally makes their regulation, suddenly the market will be flooded with EU AI quality management consultants.
Yep.
And we'll say, where did they all come from?
Yeah, probably already starting is my guess.
Yeah, just like GDPR was. All right. Well, Will, thank you so much for being on today. This is a really, really critical topic. I'm so thankful that you made the time and your team made the time to sort of connect us and get this set up. So thanks so much for the time today. And I can't wait to see what comes next for you and TruEra. Thanks so much, Troy. I really appreciate it. Thank you. Absolutely. So that brings us to the end of today's Productive AI podcast with Will Uppington from TruEra. And I really hope you enjoyed the episode. Please check out the show notes